Back in this video, I'm solving Leetcode problem 769, max chunks to make sorted. Okay, this video will be in a bit different format, so it will be live kind of. So yeah, I think this format is a bit better just because I started doing Leetcode like, as you can see, since I've been publishing those videos, and I think it's cool to see the progress, because when I do it live, then you can see all the mistakes I make and everything. And let's hope that through the time, even I'll get better, and even you watching this video and solving Leetcode problems will get better. So let's get it. So we have a medium today. Okay, so we are given an integer array of length n that represents a permutation of the integers in the range of 0 to n minus 1. Okay. To sort the array. So return the largest number of chunks we can make to sort the array. Okay, in this array, example 1, we can't. So it's 1 because we need to sort all of them. And in this one, we can split here. So we have 0 and 1. So this part for sure. And what's the size of a chunk? So chunk can be of size u(1). Okay. So I have only 10 elements. Okay. Between 1 and 10. So and I need to split in the chunks and directly concatenate them in that sorted array. Okay. Okay, so wasn't n is length, and okay, this can be 0. Okay, so from 0 to 9. Well, I think I have kind of the idea. So first we need to search for index 0. Like in this example, we are at position 0. We are at index 0. And we check the value. If the value is not 0, we go further, and find the 0. And if the 0 is whole array, then whole array. Okay. And then we go to the next one. So chunks are either But what if it's this? What if 0 was here? So I would go till 1. Mm-hmm. Mm-hmm. So for sure, um, if the element is on the right position, I consider it as a chunk, like this example. So 2, 3, 4 will be a chunk. Each number will be a chunk for itself. And that's first thing. And for the rest, hmm. And for the rest, we also need to. But what if, let's say, 0 was over here? We'd still have to take all. Okay, it's kind of interesting. So not sure if that's right approach what I said, because maybe there's some other idea. Because if I search for, let's say, 0, so I'm at 0 index and I want 0 to be here, then I have to search for that 0 somewhere, but maybe that's solution. Maybe that is solution. So okay, I sorted. I think I got it. So I'll search for a 0 and I sort what I have. I search for 1, find the 1. If it's good, it's good. If it's not good, I sort what I have. Or if it's not good, then it shouldn't be in a chunk. Okay. This tells me it will probably be a pretty bad time complexity, so we'll have to do some crazy things. How do I start this? So I have to find the position where all maybe I got it. So I have to go through all the positions. So, and if it's not correct, I have to find the maximum position, so I need to find the maximum value from that chunk also will have to be included. So okay, I think that idea would be solid. So okay, I think that idea would be solid. So I would go for I in range length of array. Yep. So so let's say target is currently 0 to be sorted. So search for 0, but track highest maximum found. Search for target so maximum will be or we won't have maximum at the moment, so maximum will be, let's say, 0 again. I think that's correct. So or let's put it now. Okay, if target is equal I and target is equal array of I, then we have chunks will be 0, chunks will be plus equal 1. Else, if it's not true, and target is next one. I'll probably fix this one, but let's let's leave it like that. So else or let's fix it immediately. So if target is equal I, if target is equal I, well, target will always be I. If target is equal to I and if our array of I is equal to target and maximum is equal to okay. So if I have, let's say maximum is 4, I know that up till index 4, we need to sort it for sure. Okay, I'll go here, I'll stop at the 4. I'll see maximum is 4, and I know that I need to, okay, if maximum to length of array -1. Yep. And chunks +1. This case, so maximum is equal to 1. But what means if I find, if up to some index I haven't, the maximum is, okay, yeah, makes sense. So if maximum is up to some index, if maximum is that index, then there is no greater value, let's say. So in this case, well, if maximum, okay, now I have to, let's forget about this one. So this is like maximum mode. So if maximum is greater than okay, up till this index, it's so if okay, so I need to have I think I'm getting closer. So this is one approach, but second thing is, so I have 1. That means that I have to go till index at least 1 and see if it's sorted. But if it's not, I have to find what's the maximum. So how can I do that? If how can I do that? So I have maximum in error of 5. I have to go as long as until maximum is equal to I. Maximum is equal to I. That's where I need to go. It's just the way it is. Now maximum is equal to I. So if maximum is equal to I, then I then I have to chunk will be plus equal 1, sorted index will be I, and maximum stays the same. I think this one is pretty easy, but well, not easy, but if I'm correct, so the idea is, let's say we have 8 of them, so we have 4, 5, 6, 0, 2, 7, 1, 3, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7. So let's say we have this. First we have maximum and 0th element. So our maximum is 4 now, but that's not the length, so nothing. We have 5, but that's also wrong position. We have 6, that's also nothing. 6 is the highest at the moment. We have 0, that's also bad. 2, 7. Okay, so we found maximum is, if we found maximum, yeah, but this has to be okay, maybe I got it. So I'll have 7, and I know up until that index everything needs to be sorted. If it's the last, then it's the last chunk. But the idea is, if it's enough when I arrive, let's say it was this situation. So I found 6 and I came here at the 6th index. I know all of these needs to be sorted. And then I go to the 7, and if 7 maximum is length array minus 1, and it is, I return just chunks plus 1. Okay, this is good idea. Even I don't need to do it like this, but if maximum is I, if maximum and I are equal, then we can, I don't need to necessarily return, but chunks need to be chunks plus 1. This should be a good idea. So let's see, in this example it will be 4. 4 is not I, so nothing. Okay, so this condition I already have. Okay, I think, man, if this is correct, then it was pretty easy. So if maximum, let's say in this, so we get 4, and some, let's have minus 1 here, so 4, anything will cut it, so 4, it's not equal, I have to go through next one, so 3 not equal, maximum, also go through 2 not equal, maximum, also, and I'll increase one chunk, and that's it. I will return here chunks. Okay, let's see this example. So I have 1, maximum is 1, but nothing happens. I get to 0. Maximum is maximum is equal to the index. I increase chunks, and sorted index is up until here. So then do I need this sorted? I'm not sure I need it. Let's remove it. So then I go to the 2, it's equal, I increase chunk, 3, it's equal, I increase chunk, 4 is equal, I increase chunk. This should work. But let's see other way around. If we had like, let's have 0, let's have 2, 1, 0. Now let's say 3, 4, and then have 7, 5, 6. So I'll go to number 2. It will be maximum, so nothing here. No increase until 0. I'll get to the number 3. No, I'll get to the 0, and maximum will be equal to index. So all to the left is sorted. That's the idea. If true, all to the sorted. Okay. Then I'll get 3. 3 is equal, sorted. 4, 4 is equal, sorted. Then I'll get to 7. And then I'll have to go 7, 5, 6. I think this is correct. So no need to target, no need of anything. I'm not sure. This seems too easy. Let's try it out. Okay. Okay. pretty interesting. So yeah, as you can see, I got a bit stuck at the beginning, but seems pretty easy. Pretty easy. Okay, let's see time. Even though, as you can see, if we can see the, I'm gonna need maximum. I need maximum. Chunks I also need. So crazy, crazy. It's this easy. Really crazy. So time complexity of n, because we go through all of them, and space complexities all of 1. What? Crazy. I'm not sure why it's required this much, but yeah. Let me check this one. This is pretty crazy question, because when you look at the constraints, you only have 10 elements. I would assume then we have some crazy complexity, because why wouldn't we have like more elements? Let's see some hints. As the smallest k, for which k up to k plus 1. Okay, it's kind of this idea. But yeah. Interesting one to solve. Okay. I hope everything made sense. You could see I had some trouble at the beginning, but the idea came through a bit of thinking. So yeah, if you have any questions, leave them in comments. I hope everything made sense, and see you in the next one.